we stop there. u1x equals to minus x by 3 and u2x equals to minus 1 by 9 e to the power minus 3x. Okay. So, and you got this phi 1x, phi 2x already there, right? What is phi 1x? E to the minus x, and phi 2x equal to 2x. Okay. So psi t equals to, you got minus x by 3 e to the power minus x minus 1 by 9 e to the power minus x. And psi x is this x minus x by 3 e to the power minus x minus 1 by minus x plus c1 phi 1x, which is e to the power minus x, plus c2 is e to the power 2x. Okay. So if you look at these two, you can actually combine. These two you can combine. So what you can actually write, you can write c1 prime, c2 prime. You can write x minus x by 3 minus e to the power x plus c1 e to the power minus x plus c2 to the power 2x, where c1 equals to c1 prime minus 1 by 1. That's the answer. Okay. So this is the way to combine, because minus 1 by is constant and c1 prime is constant. Combine these two constants, right? Nothing else. When combine these two constants. So this is a very cute way to represent the solution. It's a very cute way to represent the solution. Right? Clear? So next we'll be going for next question. So now we have learned a generalized way to solve a non-homogeneous differential equation. Now you are very much bored. Any kind of non-homogeneous differential equation is given to you. You know how to do it. No need to worry about 1 by d square and all those things. That creates a lot of complexity. Sometimes you have to do partial fractions and all those kind of things. You don't need to worry about. Directly you can attack and solve it. Okay. So now can we apply this for the higher order differential equation? That means what I am saying. If we have Ly, which is y to the power n, y nth order differential equation, a1, yn minus 1, and an 1. And of course, the trial solution, you know that it is what mx. If you do the trial solution, the characteristic polynomial will be what homogeneous equation? It should be m to the power n plus a1 m to the power n minus 1 plus it is an n equals to. Sorry, an equals to. And if you solve it, you get the roots. Okay? And the same process. What is the solution? Your solution will be y equals to summation I equals to 1 to n, if there is the number of roots, c I e to the power m I x. Am I correct? I am assuming all roots are different. If the roots are not different, the different kind of formula will be there. So it is m1 is not equals to m2, not equals to. Okay? If it is equal, if it is equals, you know how to do it. We have done it. Two different ways we have actually. One is this way, another one we can do by dy dt equals to at or dy dx equals to ax. Okay, if you want, any such differential equation you can convert to a state of first order differential equation. We have done, and from there we have derived it. So let's take up one quick example to apply for the higher order differential equation. Let us take up one higher order differential equation. Y triple prime minus 3y prime plus 2y equals to. What is my characteristic polynomial? M cube minus 3m plus 2 equals to 0. What are my roots? M equals to 1, 1 minus 2. See, the two roots are equal. The two roots are equal. So now the situation is, what will be the solution? Phi 1 equals to the power x. What will be phi 2 then? Solution basis. You know how to get solution basis. We have done it. What is the solution basis? Phi 2 is? Phi 3 is? Okay. So phi x, my final solution is yx equals to c1 into the power x plus C2x e to the power x plus C3 e to the power minus 2x. Very simple to extend the concept. Now the thing is that we have done nicely. This is not completely correct because we have said that okay, this is possible. This will not satisfy the equation. This will satisfy the linear operator and everything. But are they independent solution? So we are waiting for the wrong scale. So let's look at the wrong scale and see the wrong scale is non-zero. If the wrong scale is non-zero, okay, they form the solution basis. Okay, so the proof phi 1, phi 2 and phi 3, which is phi 1, phi 2, phi 3, phi 1 prime, phi 2 prime, phi 3 prime, phi 1 double prime, phi 2 double prime, phi 3 double prime. Okay? What is that? E to the power x, x e to the power x, e to the power minus 2x. Okay? Next. E to the power x again, and then e to the power x plus x to the power x, and then minus 2 to the power minus 2x e to the power x, then 2 to the power x, then plus x e to the power x, and then plus 4 e to the power minus 2x. Definitely it is non-zero. You can prove it. Definitely it is non-zero. So that means they form the solution basis. Right? That means they form the solution basis. Now, I will, before proceeding further, for the non-homogeneous solution. So what we have covered? We have covered homogeneous differential equation, second order, and we found solution basis. We found the non-homogeneous second order differential equation. Next, we went to the homogeneous higher order differential equation. They are covered. And now we will be going to non-homogeneous higher order differential equation. Before going to that, I want to see how this Ron scale can be developed in a generalized manner before getting into the higher order non-homogeneous differential equation. So the theorem is let phi 1, phi 2, phi n be the solutions of Ly equals to 0 on an interval I containing x0. x0 is initial condition. So then it can be proved that phi 1, phi 2, phi n, which is a function of x, equals to w phi 1, phi 2, phi n is a function of x0 e to the power minus a1 x minus x0. Okay? This is the theorem. Let phi 1, phi n be the solutions of Ly equals to 0 interval containing a point x0. Then w phi 1, phi 2 n, any order, no problem, x is nothing but x0 e to the power minus a1 x minus x0. Right? This is the theorem, and we are not going to derive all those. And in fact, we have seen this kind of things earlier. When I talked about the second order differential equation, we found that W satisfies the one-order basic differential equation, and this kind of things will be valid. So this can be proved for the higher order differential equation also. This solution would be satisfied. Okay. So this you can prove. Please prove it. This could be the exam question. Prove it by class notes. It is there already. You have proved it for second order. Can you prove it for the higher order differential equation? That's my question. It was proved actually. I think last class or maybe before that. We look at this has been proved for the second order differential. W phi 1 phi 2 because W phi 1 phi 2 x0 if you call minus x a1 x minus exactly the same thing we have proved for the second order differential equation. Higher order you can prove it. Maybe Vasudha can give it to you. Maybe many. I have given many such assignments we have not given last time. That function of space, vector space. Okay. Yesterday actually I was actually before getting to the non-homogeneous higher order, I was thinking about very interesting question. We have 1x, x square, the three basis functions. Okay? And what is the corresponding vectors to this one? Okay? Similarly, we have 1, 0, 0, 0, 1, 0, 0, 0, 1. What is the corresponding functions to this? Basis functions. What is that? 1x, x square you don't satisfy. 3 points are there. I am selecting 3 points. Maybe 0, 1, 5, 1. Okay? You can represent with this, or you can actually represent x1, x2, x3. No problem. What will represent? So that means 1, 0, 0. For these things, it will be 1 here, 0 here, 0 here. For these things, this thing it will be 0 here, 0 here, 1 here. For this, it is 0 here, 0 here, 1 here. Okay? These basis vectors are orthogonal. We look at orthogonal basis functions. Okay? So this kind of things actually is coming in my mind, and any such questions can come in the exam. I am giving a lot of questions. This may be the exam question. What could be the function? What could be the function? This is the basis vector. So basically, if you look at this is nothing but 1 here, 0 here, 0 here. Okay? I am actually converting the function to this solution. What the function? Okay, think about it. This could be the exam question. Now we will be going for the non-homogeneous equation of order. Non-homogeneous equation of order n. What is that equation I am referring to? Yn a1 y to the power n minus 1 or y of n minus 1. We have an of the y equals to bx. This is the most generalized non-homogeneous equation of order n. The non-homogeneous equation of order n could be cubic derivative, fourth order, and so on. If you want, where is the application of this kind of differential equation? There is a topic called thin film. I am working also in this area. This has fourth order differential equation. I solve for that. This has fourth order differential thin film. The direct application. Where in chemical engineering, painting. You do painting, right? These kind of paintings are there. The thin film. If you want to do the modeling of that, the fourth order differential equation. On that. So you need to know fourth order differential equation. Otherwise, you cannot do painting. If you want to look at, of course, a painter doesn't know a differential equation. But if you want to know more of the physics part of things, of course, you need to have the fourth order differential equation. So definitely you need to know the higher order equation and of course the non-homogeneous stuff. Okay, so what is the solution? Can you tell me what's the generalized form of the solution? What's the generalized form of the solution? What is phi p? And then what is psi? Psi p is u1 phi 1x, u1x phi 1x plus u2x phi 2x plus unx phi x. And psi is psi p plus summation ci phi ix I equals to. This is the solution. Now, if you recall, for the second order differential equation, what we did? For the second order differential equation, you know that we had to solve for u1 phi 1. Right. Second order differential equation. You have to solve for u1. What was the thing? u1 phi 1 prime plus u2 phi 2 prime equals to 0, and u1 prime phi 1 prime plus u2 prime phi 2 prime equals to b. Right? No? Just a minute. Phi 1. Somebody told me phi 2 prime, u2 prime. Yeah. Okay. That was the solution. Same thing will apply here. Same principle. So what actually happens? So psi p equals to u1 phi 1 plus u2 phi 2 plus un phi 2. If you take psi p prime, it will be how many terms? Each will be having two terms, right? But with this, so that means I am actually developing the equation for nth order. What I am assuming? I am assuming u1 prime phi 1, u2 prime phi 2, and then un prime phi n equals to 0. If I assume it is nothing but psi p prime will be nothing but u1 phi 1 prime, u2 phi 2 prime, and you have un phi 1. Psi p double prime. Okay? So now I'll assume u1 prime phi 1 prime, u2 prime phi 2 prime, un prime phi n prime, sorry, u1 phi 1 double prime, u2 phi double prime, un phi n double prime equals to 0. What is phi p double prime then? So if it is this, what actually happened? You can have two derivatives, u1 phi 1 double prime, and then phi 1 prime u1 prime. So phi p double prime is what? You can actually do, instead of doing that, what I am planning to do is, okay, then what will actually happen? Then what is phi p double prime? u1 just a minute. u1 phi 1 prime and u2 phi 2 prime, then phi prime equal to 0, right? There you go. Sorry, this is 0. So phi p prime is u1 phi 1 prime. This part is okay, right? Yes. Okay. So if this is the case, what is the psi p double prime? I want to get in this fashion. Then what should be 0? That's what I'm asking. What is that? Right? Am I correct? Yes. Okay. Next, if it is, then psi p, I should write 3 because I should not go on writing. What is the next equation then? u1 u2 phi 3 un phi n 3. What is the equation then? I am actually planning to have this type of equation here. What is this equation then? Double prime, u2 prime phi 2 double prime, and un prime phi n double prime equals to 0. After that, I will go to psi p, say n minus 2. I should say n minus 1. Then finally go to n. So in n minus 1, what will actually happen? u1 phi 1 n minus 1, u2 phi 2 n minus 1, and you get un phi n n minus 1. So we have u1 prime phi 1. It will be what? For phi p it is n minus 2, right? Yes. u2 prime phi 2 n minus 2, and un prime phi n n minus 2 equals to 0. Last is psi p n equals to u1 psi 1 n, u2 psi 2 n, and un psi n n. Then what is the last equation then? u1 prime phi 1 n minus 1 to un prime phi n n minus 1 equals to 0 b. Why it is b? Because this equals to b, right? And then you got the psi p. Psi p is equal to n. So that's definitely is equals to b. All of you understood why it is b? No? Why no? Who can explain why it is b? Who can explain why it is b? Yes. So basically, you actually, this is up to this, everything is clear. If you take derivative, what actually happened? So you have u1 prime phi 1 n minus 1, u2 prime phi 2 n minus 1, and so on. This will be there, and then you will have u1 phi 1 prime and all those things. So now the thing is that there is a last one, and your final equation is having the equals to b. So it should satisfy the differential equation. Based on differential equation, this has to be equals to b because it satisfies the differential equation. The differential equation is this entire thing equals to bx, right? Is the formula clear? Okay. So what will be your Wronski and all those things? I don't want to derive Wronski here. Better to go to the actual problem and solve the system. So the thing is that for this type of system, you need to see that u1 prime, u2 prime, un prime, you are going to solve. Once you solve u1 prime, u2 prime, u2 prime, you take integration and you get u1, u2 the same way what we have done earlier. So let's take up, instead of talking about this derivation, maybe what you can do, you can pick up third order differential equation. The same way what we have done in the class, you can do the derivation. We appreciate. What I didn't do the derivation. I was just showing how the equations are coming. Okay? I don't have time to derive. Last time some of your seniors actually they derived and gave me the assignment. What they did, third order differential equation they picked up like this, up to 3. And they got the 3 equations. If you do it, we'll appreciate it. So if you want to know why it is coming, of course I will not give you the answer here. You derive yourself, you get it. I just gave you some way, some shortcut way. This is not the derivation, the shortcut. If you want to derive it, I have done for the second order differential in the class. You do for third. The same. Then you appreciate it. And if you submit to me, you get it. So let's look at. So let's look at y triple prime, y double prime, y prime plus y equals to. Now what differential equation? What's the characteristic for it? What is the characteristic for it? Pardon? N cube plus n plus 1 equals to 1. What's the solution? What is the factorize? Can you factorize and tell me the answer? Minus 1 is there, always definitely. Then plus minus 1 is okay, other two terms will be equal. Complex quantity, okay, how much you are getting, Vasudha? Plus minus I. So correct only. Okay, so what I will write, my phi on x e to the power minus x, or I just write cos x. Last one, based on this. Phi 2x, I will write sin x. Better to write this way. I minus I 1. This is the way I am arranging it. E to the power minus x. Remember that if in the differential equation, second order differential equation, we have done only 2 cases. When m1 and m2 they are real and not equal, you get the solution simply for m1 x equal to m2. If they are equal, you get x equal to whatever x always is. If they are complex conjugate, the solution is cos x and sin x. So we are doing the third case here. So solution is cos x sin x for third case. Why? Because solution is generally e to the power ix e to the power minus ix. So it will be c1 e to the power ix, c to the minus ix. So you can write, we know that e to the power I theta equal to cos theta plus I sin theta from De Moivre's theorem. Okay? So c1 cos theta plus cos theta means cos x plus I sin x plus C2 cos minus Ix, that is cos Ix, minus plus is minus sin x. Am I correct? Cos minus is equal to cos theta. So now you can see C1 and C2 if you combine, you get a new constant called C1 prime cos x and C1I and C2 minus C2, the new constant called C2 prime, which is C2 prime sin x, and that's what. Now you can say this form the solution basis. That's the way. The quick calculation you can do that. I have not done it, but this is the way you can do it. This is the way you can say that these are solution basis, cos x and sin x. So cos x, sin x, and u minus x. Okay. So after that, of course you got the complementary function, which is phi 1x, c1, phi 1, c2, phi 2, c3. There is not an issue at all. Our issue is to find out the non-homogeneous part, which is particular integral. Here is a kind of solution. What is the solution? Side B, which is u1 phi 1 plus u2 phi 2 plus u3 phi 2, which is of course u1x phi 1x plus u2x phi 2x plus u3x phi 2x. Right? So what will be my three algebraic equations? After that, what are my three algebraic equations? Yes. u1 prime phi 1, u2 prime phi 2 plus u3 prime phi 3 equals to 0. u1 prime phi 1 prime, u2 prime phi 2 prime. Remember that is u1 prime, u2 prime will not change. If it changes, you are not able to solve the u1 prime, u2 prime. So definitely, if you remember the formula, you know that u1 prime is fixed. Only you have to increase the other term, which is phi 1 prime, phi 2 prime, and phi 3 prime. Okay, and the last equation is u1 prime phi 1 double prime, u2 prime phi 2 double prime, u3 prime phi 3 double prime equals to 0. That's it. Okay. Yes. What is my long scale? W phi 1, phi 2, phi 3, x equals 2. We should not write matrix determinant. So this should be vertical. You give me the answer. What is first you have to get in long scale? Before coming to that, I want to have long scale from phi 1, phi 2, phi x, phi 3, which is cos x, sin x, e to the power minus x, minus sin x, cos x, minus e to the power minus x, and then minus cos x, minus sin x, plus e to the power minus x. If x equals to x0 equals to 0, and here a1 is what? x0 equals to 0, I am assuming. What is my a1? What is my differential equation? A y is nothing but yn plus a1 yn minus 1 plus a2 yn minus 2. So what is my a1 in that case? 1. Yes, sir. So what is my Wronskian? Phi 1, phi 2, phi 3 at x0 equals to, what is that? 1, 1, 0, 1, then 0, 1 minus 1, minus 1, 0, equals to 2, right? So what is my W phi 1? Phi 2, phi 3x equals to, which is W phi 1, phi 2, phi 3, x0, e to the power minus a1, x minus x0. Am I correct? It is 2 e to the power minus x. That's it. Very interesting. You got 2 minus x. Now, what is my u1 prime x? From here, you can actually find out. So now you know what is phi 1 prime, phi 2 prime, and all those things. So we have to use the Krammer's rule. If we apply the Krammer's rule, what actually happens? So U1 prime, if you replace, then this entire row will be replaced by 0, 0, B, which is 0, 0, 1. Other rows will be same, which is sin x, cos x, minus sin x, e to the power minus x, minus the minus x, e to the power minus x. Am I correct? Yes or no? Correct? Yes? Yes? Okay. Amit, everything is fine? You are not talking today? What happened? You are writing. I thought you were angry with me. Okay. Yeah, what's happening? Tell me the answer. U1 prime x.
1 by 2 cos x minus x.
Minus half. Not 1 by 2, minus half cos x plus sin x. Check your determinant. Is it correct? Minus half cos x plus sin x. U2 prime x. I want a quick answer from you. I will not do these steps. These steps are your responsibility. U1 prime you got. U1 prime you got. U1 prime we got. U2 prime x. Pardon? No minus will be there, U2x. U2x, U2 prime x. 1 by 2, yes. Cos x minus sin x is okay, not minus 1 by 2. Okay? And U3 prime x is? That's very easy. U3 prime. Amit, you are not able to find determinant? 3 by 3 only. If you forget the formula, you can use my formula what I have given, which you cannot forget. Only 3 factorial comes, 6 terms will be there. Then only 3 factorial comes. Pardon? What is that? 1 by 2 to the power? No. E to the power x. Yes. You are having some always some extra minus in your life. I don't care, no matter. You have some extra minus in your stock. That's okay. Don't use in maths course. If you can use in something for expenditure, that is better. You can save a lot of money. In the maths course, you'll be getting 0. Okay. So U1x is equals to what? U1x equals to U1 prime is given. So U1x is integrate and give me the answer now. What is that? U1x, U2x, and U3x. Very fast you should be doing. Integrate, get me the answer. And that's it. You are done with that. First one is only 1% please. Minus half is not important correct answer. Plus half cos x minus sin x. Next half sin x plus cos x and half e to the power x. Now what is your particular integral? U1 phi 1 plus U2 phi 2 plus U3 phi 3. You get a very cute answer, tell me. Very nice answer. What is the answer? What is the answer? 1? Who got 1? So find an answer. What is that your equation? The equation is final solution is psi x 1 plus c1 cos x plus c2 sin x plus c3 e to the power minus x. Even if you can see from here, this long scale, we have proved at x equals to 0, at x equals to 0, we proved this wx is non-zero. So that again shows that sin x, cos x, e to the power minus x are independent solutions. We have shown here for the first time. This kind of case we have not considered earlier. So we have solved many complicated differential equations very fast, right? So this is one of the complicated. So now we can tell that okay, you can solve linear higher order non-homogeneous differential equation. We can solve even a fifth order differential equation if I give, we can solve that non-homogeneous by the long scale approach. We have not seen this kind of method earlier, right? This is generally being taught in the postgraduate level of mathematics department, not in undergraduate mathematics. So what we are doing actually, it is generally covered is MSc, MPhil or PhD in mathematics course. So that is the level actually you should learn the stuff. Next, before going to my next portion of the differential equation, which I was actually, when I was doing my PhD, I was very much fanatic towards mathematics. Of course, you know that how much fanatic towards, and this was there. That's what I never liked chemical engineering, because chemical engineering does not have that much mathematics. And during my PhD, I was going to only mathematics department to take the course. I was completely bored by the chemical engineering department courses. So one of the courses I took in the mathematics department is nonlinear ordinary differential equations and partial differential equations. So some of the nonlinear ordinary differential equation parts, what I have learned during those days, I will be sharing with you. After that, before that, I would like to recap of our integral formulas, what we have learned in 10 plus 2. So formula for integration. Number 1, integral yn dy, which is yn plus 1 by n plus 1 plus c integration constant, n is not equals to 1. Second formula is very easy, integral dy by y, ln of mod y plus c. Third formula, integral a to the power y dy, 1 by ln a to the power y plus c. Similarly, e to the power y dy, which is e to the power y plus. These are all known formulas, right? We have seen this kind of formula. Number 4, integral cos y dy is sin y plus c, and similarly integral sin y dy equals to minus cos y plus c. Number 5, integral cos hyperbolic y dy, which is sin hyperbolic y plus c, and integral sin hyperbolic y dy, which is plus cos hyperbolic y plus c. There's a difference here, minus cos and plus cos hyperbolic. Then check with a formula that you can actually appreciate better. Number 6, integral dy by cos square y, which is tan y plus c, integral dy by sin square y, which is minus cot y plus c. Number 7, this formula you will be using next when we are doing the non-linear ordinary differential equation. So far you have done linear operator. Next we are going for non-linear operator, right? Because in vector space there is no question of non-linear operator, because matrix is constant. But in the functional space, there is a chance to have non-linear operator. Okay? And simple non-linear operator is y dy dx. The non-linear operator, right? Y is here. Simple non-linear, some simple cases is a non-linear operator. When this kind of term is there, d2y by ds square is linear operator, no problem. But if you have y dy dx is a non-linear operator, how to solve this kind of problem? We don't know that. So that's the part we will be going to cover. And that time, you need to know this formula. We need to know this formula. So the second formula, integral dy by y square plus s square, which is 1 by a tan inverse y by a plus c, which is also minus 1 by a cot inverse y by a plus c, a greater than 0. Number 8, integral dy s square root over s square minus y square, which is, what's the formula? Do you remember? What is the formula? Let's see that. Who remembers the 10 plus 2 integral formulas? What is that? Any hands, please? And tell the answer. Any hands? If you are all knowing this, I think so many hands will be coming. No hands coming. Yes. Sin inverse? Sin inverse y by a plus c equals to minus cos inverse y by a plus c, a greater than 0. Number 9, integral dy square root of y square plus minus a square, which is equals to, who can give me the formula? Do you remember? Of course you may not, because we will complicate formula. We have done it earlier, y plus square root of y square plus minus a square plus c. Number 10, integral dy divided by y square minus a square, which is 1 by 2a ln of mod of y minus a plus y plus a plus c. So this formula we need to remember. This formula we need to remember, right? So with that I will start the steps to solve. So we will be two things will be covered in here. One is called two portions will be covering. First portion is non-autonomous and autonomous non-autonomous and autonomous differential equation. Number 2 is nonlinear ODEs. Do you have any idea what is called non-autonomous differential equation? Okay. If you have this type of equation, x squared into y dx square plus x dy dx plus y equals to 0. If you look at the independent variables are appearing in the differential equation. Earlier, independent variables are not appearing in the differential operator. Now, independent variables are actually appearing in the differential equation. Earlier, what kind of differential equation we had? d2y by dx square plus, say, 3dy dx plus 2y some dx. This is the operator Ly. This is the operator Ly. In this operator, if you see that independent variables are not coming, it's numbers 3 and 2. Here, independent variables are appearing. This is called as non-autonomous differential operator. This is the autonomous differential operator. So one is non-autonomous differential operator. Another is autonomous differential operator. So in that case, if you have non-autonomous system, how to solve it? This type of equation you might have seen earlier. You didn't know the non-autonomous, but you solve also. What is the type of differential equation? What do you call this differential equation? Cauchy-Euler type. This is the differential equation called as Cauchy-Euler differential equation. This is the famous non-autonomous differential equation, which is known as the Cauchy-Euler differential equation, which is known as the Cauchy-Euler. So this is the famous non-autonomous differential equation. Second is the first part. Second part is nonlinear ODE. What are they? Say for example, y double prime equals to say b. It's a nonlinear ordinary differential equation. Okay? Or in chemical engineering, quite often you have this kind of term, energy balance equation. This is a advective term. Or in Navier-Stokes equation, sometimes we will be having this term. It's the same thing. So this leads to advection in chemical engineering. Leads to nonlinear ordinary differential equation. Advection. ADVECTION advection. Next semester I think we will cover in transfer program on course. Advection. Advection term leads to the. So there is something called convection, something called advection. So why advection occurs? When fluid moves, the fluid particle carries the temperature with them. Okay. So what actually happens? Hot wall and cold wall. Conduction means some temperature will be provided with that. If there is a fluid, what actually happens? Conduction is a molecular phenomenon. What actually happens? This guy is having higher vibration, this guy is having lower vibrations. Initially, all vibrations same. So these vibrations, you put hot and cold, this will be vibrating much faster. This will transfer vibration. This will transfer vibration. That will be affected as temperature. The molecular phenomenon. If you have fluid, what actually happens? Fluid particles try to move like this. Hot wall means density is low. Cold wall is density is high. So this side fluid will go up and then fall. So what actually happens is fluid particle, they are actually carrying the temperature. This is called advection. This is called advection term. That's why this term is coming. If you indicates. And that gives a nonlinearity the differential equation. That gives the nonlinearity the differential equation. Okay. Let's how to solve it. This type of problem. So which is having much relevance. So this type of non-autonomous system you can get in chemical engineering if we have cylindrical coordinate system or spherical coordinate system. We can get this non-autonomous differential equation, and quite often you get the solution as Basak functions. These are the results of the non-autonomous differential equations. So all these things actually are coming in chemical engineering. You have the fluid mechanics, you have the fin type problem. For example, you have a fin type problem. You have a conical fin. You have seen this kind of fins, right? Conical fin. You have solved this kind of problems in heat transfer, and there we can get non-autonomous differential equations. So many things that I am not going to cover. I am just talking about the mathematical preludes what we need for chemical engineering. So steps to solve nonlinearities. Steps to solve. Okay, so steps to solve. Nonlinear ODEs. First is symmetries. So this helps to perform following operations. This helps to perform following operations. Then this is non-autonomous to autonomous. So I am just giving the ideas. I will explain all the steps. So if you have nonlinear ODEs, you need to solve the system. First step is to check the symmetry, whether it is having the X symmetry or Y symmetry. What is the symmetry I will discuss? Once symmetry is done, it is possible to convert non-autonomous to autonomous, because most of the time autonomous guys are easy to solve. Of course, Cauchy-Euler time is a special case. If you don't have the Cauchy-Euler time, it is difficult to solve. And autonomous things you have seen that it is easy to solve. If the equation is autonomous, the equation is autonomous, then the order of the equation is reduced by a substitution, which is dy dx equals to a1. Number 4 is linearize, and number 5 is transform difficult nonlinear ODE to difficult nonlinear ODE to simple nonlinear ODE.
Finished on